Okay, now let's about problem 5. So before we start to answer all the questions, we can see what are the conditions we have in this problem. So the customer flow at a grocery store can be viewed as a Poisson process. So, and now we have the model as the probability that the number of customer arrivals in how many minutes? 0 to time t equals to k. And this probably follows the model as e to the power of minus lambda t, and all these times lambda t to the power of k divided by the factorial of k. And we are given a condition that the probability that in 2 minutes at least one customer arrives, it equals to 0.3. So here has had a condition as 1 minus its complement set event probability that the number of customer arrival in 2 minutes, like 0 to 2, and this number equals to 0 is equals to 0.7. Since since here has at least one customer, so its complement is no customer arrive in 2 minutes, and this part is equal to 0.3. And now we can have the probability that the number of customer arrivals in 2 minutes, and this equals to 0, and this one equals to 0.7. And now we can start to solve the problem. So first one is to find the lambda in the model. In the Poisson process model. So now we have, if given by the condition that the number of customer arrivals in 2 minutes and equals to 0, it equals to 0.7. In this case, we have time equals to 2 and the lambda equals to 0. Is k equals to 0. And so, using the Poisson process, we have E lambda t to the k and k factorial equals to, it becomes E to the power of 2 lambda, and then is 2 times lambda to the power of 0 and 0's factorial, and this part equals to 1, and here is also 1, so we have e to the power of negative 2 lambda, it equals to 0.7. So solve by 8 by London. then the lambda equals to ln 0.7 divided by -2 equals to, is around equals to 0.178. So first problem is solved. And the following questions are all about finding the probability using this module. So for the second one, if we rewrite it by find the probability that in 3 minutes no customer comes, it can be rewritten as the probability that the number of customer arrivals in 3 minutes is from 0 to 3, and this part equals to 0. So we can have the time equals to 3 and k equals to 0, and put all the things into the formula as and equals to it is around 0.586. So the third one, we asked to that find the probability that in 10 minutes at least 2 customers will arrive. So it can be considered as a complement set since at least 2 customers is hard to find. So its complement even it will be no customer come or 1 customer comes. In 10 minutes. So this event can then use our format. It can be rewrite as, so in this event we have no customer comes in 10 minutes and 1 customer comes in 10 minutes. So it can be the summation of these 2 probabilities, and it can be rewrite as the number of customer arrivals in 0 to 10, and it equals to 0, and plus the probability of the number of customer arrivals in 0 to 10 minutes is equals to 1. And still use the formula for we find the for the Poisson process. So we have the result. I didn't need to write the formula, but we can see the result is equals to and substitute all the values here for lambda equals to 0.178 and it equals to 0.531. So for the first problem, we have to find the probability that 1 minute is exactly one customer to write. So it's easy to just see that it can be read not as the probability that the number of customer arrival in 1 minute, it can be say 0 to 1 in this range, and this one equal it to exactly 1. So write it as e to the power of negative lambda and lambda to the power of 1, and here is also 1 factorial, so it's lambda e to the power of negative lambda, and substitute the lambda equals to 0.178 here, and we can have the result as 1.149. So all the problem is done here.